Okay, well, it's time to try and solve another equation that contains fractions. And as we're already figuring out from solving equations, they start out easy and then we just get harder and harder. And what makes that kind of tough on us is that just when we think we've got something mastered, another layer of difficulty or another element of difficulty gets thrown at us. And certainly things become their toughest when we're trying to solve equations that contain fractions. But once we can get the fractions cleaned up, the equation begins to look very normal to us or very usual. And so the very first thing we want to do with trying to solve this equation is to, in fact, get rid of those fractions. Now, as we look at this and we're being asked to solve and check, let's first of all keep that in mind, is that we are going to be solving the equation, and then once we're done that, we're going to be checking the equation. So, over here on this side of the screen, on the left-hand side of the screen here, we're going to be solving the equation, and over on the right-hand side, we're going to be checking. So let me just sort of split the page up here so that we're kind of organized. And sure, let's put a line right there. Okay, so here we go with the solving component to this. So we have to look at those denominators, 4, 6, and 3, and we have to ask ourselves, what number can we multiply both sides of the equation by such that we will get rid of all 3 denominators all at once? And you often have to think about or come up with a lowest common multiple. Okay, so I'm just going to jot that down here, lowest common multiple. Well, what is the lowest common multiple of 4, 6, and 3? Well, after a little bit of thinking, I hope you develop or come up with the idea that it's 12. So because 12 is the lowest common multiple, that is what we want to multiply both sides of this equation by. So here we go. We're going to multiply the left-hand side of the equation by 12, and we're also going to multiply the right-hand side of the equation by 12. And now just filling in those missing bits, we got 3a minus 4 minus 5, 6, and over on the right-hand side we have 5 plus a over 3. So this is what the first step should look like, that we're multiplying both sides by 12. Now, depending on the equation, what the next step is can begin to vary. So on the left-hand side, if I think back to algebra, and I think back to some of the previous equations that we've been solving in the last few days, that kind of looks like distributive property to me. And so what I want to do with my next line is I want to make it look more like distributive property. So now it's going to say 12 times 3a minus 4, and then 12 times negative 5/6. The right-hand side, I don't have those same issues or those same concerns, so I'm just simply going to rewrite what I have. 12 times 5 plus a over 3. I'm now going to switch to a different color because I want to show you what happens here. So the 12 and the 4 cancel out, but they don't perfectly cancel out and eliminate each other. But when they cancel out and think of division, a 12 and a 4, when you think about division, become a 3. And so I'm just going to write a little 3 right there in place of the 12. And moving along, the 12 and the 6, thinking about division, become a 2. The 12 and the 3 become a 4. And so this is now starting to look really messy and perhaps very confusing, but the next line will start to really clean things up. So here's what the next line looks like. 3 times 3a plus 2 times negative 5 equals 4 times 5 plus a. Now what you notice, of course, is that the fractions are all gone. And this, of course, was exactly what we were trying to accomplish in the first little part of this equation and the equation solving process, is we were trying to get rid of the fractions, and we did it. So now moving forward, we're going to make the left-hand side look simpler. Well, 3 times 3a is 9a. 2 times negative 5 is negative 10. The right-hand side, ooh, this looks like distributive property, but it looks familiar enough to me that I'm going to just try and go right ahead and try and do this right away in my head because I think I have enough comfort with distributive property. Well, 4 times 5 is 20, and 4 times a is 4a. If you weren't comfortable enough doing that, you could certainly take another step or another line and, show that a little bit more descriptively. Okay, so now I hope you're looking at this equation and you're thinking to yourself, this looks way easier. This looks way more familiar and hopefully a lot easier to solve. But making sure that we still know what we're doing, we're going to move along here, and I'm looking at the fact that there are a's on both sides, and I want to fix that. So I'm going to do that by subtracting 4a from each side. So I'm going to get the a's away from the right-hand side so that they are only on the left-hand side. This is part of my isolating process, part of getting the a's all by themselves. And so now making that simpler, we now have 5a minus 10 on the left-hand side and 20 on the right-hand side. Now I want to continue trying to isolate a. I'm going to get rid of that negative 10 by adding 10 to the left-hand side, and because of the balance method, I have to do it to the right-hand side as well. And then I'm going to simplify again, and I have 5a equals 30. Now I'm almost done. I'm almost home free here. I know my next step is to divide 5a by 5 and also 30 by 5, because that will finish the isolating process, and I find out that a is 6. Or at the very least, I hope that a is 6, because, let's face it, I could have made a mistake anywhere along here, whether it be a human mistake or a mistake because I don't know what exactly I'm doing. I may have made a mistake with my algebra somewhere along the line because there's distributive property in here and collecting of like terms. So what do I have to do over on the right-hand side of the screen? I have to check, and so I'm going to do that in blue. And let's get working on the checking. So left side, right side checking. I know how that looks. I set up a T table like this to keep everything nice and organized. And I know I have to take the left-hand side of the equation and copy it down in its original form, and also the right-hand side of the equation, copy it down in its original form. And now I'm going to replace a with what I think a is equal to. I hope that a is equal to 6. Well, we're going to find out if that's in fact the case. So let's replace a with 6, and let's find out if left side equals right side. So 3 times 6 divided by 4 minus 5/6. Now I have to think BEDMAS, make sure I follow order of operations, so that's 18 over 4 minus 5 over 6. Ooh, if I'm going to subtract fractions, I need common denominators. I think about a lowest common multiple, and it's 12. So that makes 12 on the bottom. The top needs to be 54. And over here, this becomes 10/12. And so the left side works out to be 44/12. Now I could change that to a decimal or leave it as a fraction. I could put the fraction in the lowest terms, but I'm just going to leave it for now. I don't know if I need to change it and express it in a different way. Let me work on the right-hand side and let's find out. So I'm going to replace a with 6. And oh, the right-hand side is way easier to deal with. I get 11/3. Okay, now I look at the left side and I look at the right side and go, 44/12, 11/3. Well, those don't look the same, but I do realize that my fraction on the left-hand side is not in lowest terms. I can divide it by 4 on top and bottom, And oh man, look what we got here. We have some equation solving happiness here because the left side is equaling the right side. And so I'm certainly going to put some smiley faces there to show, hey, look at that. I've got some equation solving happiness. When left side equals right side, I am good. I am golden. Okay, well, that's it for this video. Thanks for watching.